Dwight Howard is a basketball player in the NBA, and historically he's made 55% of his free throw shots. These are foul shots. Now let's consider if he takes two free throw shots, which is pretty common in the NBA. When you're fouled, you get to go to the free throw line and shoot foul shots. Uncontested. Let's say that he takes two free throw shots. Let's consider the following. What is the probability he makes all of them? What is the probability he misses all of them? What is the probability he makes the first but misses the second? What is the probability he missed the first but makes the second? What is the probability he makes one of them? So part A, we know that he's going to shoot two free throws. And the question is, what is the probability he makes all of them? So let's consider what our binomial random variable would be here. X equals the number of shots made out of 2. How does the binomial model behave? Well, we say that X follows by 2.55. So what we mean is that X is going to be modeled, the discrete random variable X, which equals the number of shots, number of occurrences of made shots out of 2. We have two trials, that's n, and p is 0.55. That's the probability of success on each one of the shots. So what does this mean? Well, we have two trials, and on each trial there's a 55% chance of success. So a little better than a coin flip chance of success. So what does probability he makes all of them mean? Well, what we mean here is that the probability that x equals 2. Remember, the random variable x represents the number of shots made out of 2. So how can we figure out what the probability is? If he shoots 2 of them, what is the probability he makes all of them? Well, we want to figure out the probability that x equals 2, and we can do this by using the formula for the binomial distribution. We can use the table, which is where all the probabilities are stored from some common parameters of the binomial distribution, different n's and different p's. We can use some sort of technology, graphing calculator, something like Google, okay? You can use an applet, lots of other options available. So how does the formula work? Well, here's the formula. What we're going to do is figure out the first term, which is the number of trials we have. Choose x. So what we want to do here is figure out how many combinations are of interest to us. Then we're going to multiply by the probability of success times the probability of failure on each one of the trials. So where are we going to substitute things? Well, here's the formula. And what we're going to do is substitute n equals 2, x equals 2, and p equals 0.55. So wherever we see those letters, wherever we see the letter n, we'll substitute 2. Wherever we see the letter x, we'll substitute 2. Wherever we see the letter p, we'll substitute 0.55. And then what happens? Well, what we can do is substitute and reduce. And let's see what we get. We get 0.3025. So that's the probability that Dwight Howard makes both of them. 0.3025. So what about the table? Well, we can also use a binomial distribution table, which is where the probabilities are already given in that the formula has already been computed. So here, if we narrow in on n equals 2, because we have two trials, and we move over to the column 0.55, we actually have the probability distribution that we'll be using. And notice we'll get the same answer as what we just got before, except here we'll round it to 3 decimal places. In part B, now we want to know, well, if he shoots 2 of them, what is the probability he misses all of them? So what is the binomial random variable here? And the answer is, well, it's the number of shots made out of 2. How does the model behave? The same way as before. What does this mean? The same thing that it meant before. The question is now, what is the probability he misses all of them instead of making all of them? Now, if we're flipping a coin with 50% chance of success on each trial, the probability of making all of them would equal the probability of missing all of them. But because here we have a 55% chance of success, a little more likely than a coin flip that the ball will go through the hoop. So we want to know, what is the probability x equals 0? This is the key here, is knowing what to set the value x equal to in terms of what probability we want to find. So we want the probability that x takes on the value of 0, so 0 occurrences. So all we have to do now is substitute, same setup as before, except now wherever we see an x, we'll substitute 0. Like so. And then what we'll end up getting is 0.2025 as our probability of x equaling 0. So again, we can look at the formula, the table, and we can see right here that instead of looking at 2, we'll look at 0, and the answer is 0.203.